And often this comes in the form of giving consumers a choice between different discrete bundles that they could purchase. So there's lots of examples of this. Eric, what are some examples of nonlinear pricing you can think of in the world?
So I think one simple bundle example is like Microsoft Office.
Yeah.
Right. So they bundle all the goods together because.
Well, that's. Yeah. Okay. Yeah.
Well, because some people might like value Word at a certain amount and Excel they don't really care about, but they're willing to pay like an extra $50 for the whole package. So I mean that's an example of like.
Yeah. That's definitely very related to this. Can anyone think of other examples? Yeah, for Sean.
Like some like sandwiches at Subway, like you have to pay a certain amount for a 6-inch, but like it's only like $2 or $3 extra.
Yeah, that's a great example. Bulk discounts in commercial goods, like if you go to Costco and so forth. Punch cards for customer loyalty, another good example. New York Times goes the opposite direction. The first 20 articles are free, but then you have to pay after that, right? Pricing of cloud file sharing services is often highly nonlinear in weird ways. Income taxes, like you pay different marginal rates depending on how much you earn, right? The goal is to get consumers to self-select into the right price. So for example, you charge a lower price. Why do you have a punch card? Well, it's that you're charging a lower price to people who are willing to go through the hassle of holding on to the punch card, right? Or a lower price to those who don't value the New York Times enough to use it more than 20 times a month, right? So depending on who's willing to pay more, you could sort of get them to self-select into these different offerings, right? Now, this is in some ways not as effective as third-degree price discrimination because you have to give people an incentive not to cheat the system, right? Okay. Now, you can also offer not just different quantities, but different qualities. So what are some examples of quality-based second-degree price discrimination, Kentaro?
For quality-based, I think.
Yeah.
Sorry, second-degree.
Yeah.
Okay.
Where you offer different like quality versions of the product in order to try to get people to self-select. Don't look at your slides.
Okay. Yeah. So like the airplane stuff.
Yeah. Well, can you explain? Explain.
Okay. So like there are two classes, right? Like a business classes and economy classes.
Yeah.
And obviously the price for business class seems to be very high.
Yeah.
Relative to its cost.
Yeah.
Associated with it.
Exactly.
So
exactly.
Okay.
Yeah. So classes of service in airlines, quality of rooms at hotels. These things often don't seem to just reflect the differences in cost, but actually be trying to discriminate against people. Different levels of American Express cards. You pay a huge amount to get one of those black cards, even though they don't really, it's not really very much more costly to them to give you one of those, right? Tiers of cable and internet service are another example. And a common observation is that it seems like the low quality services are often deliberately degraded in order to try to like force people into the high quality services, right? So it's like, you know, an airline, especially legacy airlines, might make it like particularly uncomfortable in coach in like not letting you go to the bathroom, for example, even when there's this extra bathroom for the people in first class and nobody's using it and they don't let you go because you want to buy it to make you want to buy into first class to try to get that, right? This forces people who can pay for first in business to do it, right? So this leads the monopoly to distort quality as well as quantity, particularly for the low-end consumers, right? And we'll model this in 1 second.
Can we talk about
Yeah.
the American Express thing?
Yeah.
Isn't that a little hairier because we have a platform, so the people who are really good, like, right, the different quality of cards is reflective of like your credit ratings or your quality as a consumer on that network?
Yeah, I mean,
So
I think that that's
partially
true, but I
cost.
think that the thing that's interesting about that is that it actually goes in the opposite direction of what the platform effects would say, because you really want to get the rich people because they spend a lot of money on their cards, and yet you still are charging them a huge amount for the card.
Wait, how is the black card better or different than?
It's mostly better because, like, when you put it down at a restaurant, gold digging women look your way, but it also has like some travel services associated with it. I mean, I know someone who actually had one of these, and the thing that's amazing about it is like, basically American Express becomes a personal assistant to you. Like anytime you're anywhere and you want anything done, you like call up American Express and they'll sort of do it for you if you have one of these black cards. But it costs much more than a personal assistant costs to have it, so it's really like.
There's a minimum you have to spend on every year.
Oh, you have to spend like some redonkulous amount. Yeah, you have to spend like $200,000 or $300,000 a year on it or something like that. Yeah. Anyway. Yeah, Mohammed.
I was just wondering, like club pricing, for example, like they design different kind of enrollment in those clubs, and so is that nonlinear pricing or quality?
What types of clubs?
Sport clubs, for example, or like golf clubs, like so like they're like
yeah.
So because the quality is different, but also the person like those two different groups are attracted to those contracts because it's more profitable.
Yeah. So I mean, that's the sort of thing that I'm sort of trying to show here. So imagine that this is a picture of the willingness to pay for a marginal unit of quality that two different groups have. So imagine there's a group that here has a low willingness to pay overall. Like this is their willingness to pay if they get 1 unit of quality. If they get 0.5 units of quality, they're willing to pay this amount, right, and so forth. So this group has a relatively, they both have lower overall willingness to pay, but in particular, they value quality less than this group does, right? The rate at which their value for quality declines is higher, right? On the other hand, if we had these things sort of like crossing, then you would actually want to try to sort the people who are willing to pay a lot into the low quality products, because even though the people with high demand, high value, are willing to pay more, they might not be willing to pay more for higher quality products, right? So depending on how those compare, it'll be attractive or unattractive to do this quality-based price discrimination. Okay, so let me try to formalize some of these ideas. And to do this, I'm going to use Wilson's version of the Musa-Rosen model of price discrimination. So individuals choose how much quantity to buy. And this could either be quantity or quality. It doesn't really matter. And there's an equilibrium distribution of how many people are buying given quality given a particular price function you have. So you set up, there's a cost of providing individuals with a particular quantity or quality, and individuals have to pay a price, P of Q, to buy a certain quantity or quality, right? And let's assume that this price is 0 when you're buying 0, right? And this ensures that individuals are never going to sort of like jump around as prices change. That also, for that to be the case, you also have to put some restrictions on the utilities and prices. We'll talk about jumps in a minute. But imagine that there's a fraction G of Q people times epsilon who are currently buying Q, but if you were to raise the marginal price of buying just a little bit more, would reduce by a little bit the quantity that they purchase. That's sort of like how many people are just on the margin of switching down to a little bit lower quality or quantity, right? So the only people who are going to stop consuming altogether are those who are already at 0, right? So how are we going to price optimally in this case? Well, let's call the marginal price P prime of Q, right? That's how much you pay for the next unit of quality, right? And the question is, what are the benefits to you of increasing that marginal price at one point, and what are the costs? Jack, could you say, if I raise this marginal price at some point, what is the benefit I get in terms of my revenue, and what's the cost to me? Yep. So who are the people that I get more revenue from, and who are the people that I get less revenue from?
If you change the quality by one.
If I change the marginal price for a little bit more quality at one point.
The people that are less or more elastic with respect to quality, those people you'll get less, or you'll get more revenue by adjusting the price. Whereas people that are more inelastic, you won't.
Does anyone else want to try that? Eric?
So you'll lose revenue from these G and Q epsilon
Yeah.
people, because
Yeah.
when the price goes up, they'll consume a little bit less.
That's right.
The people, I'm not sure how you want them to know, the
Yeah.
people who aren't in that group, they won't change.
But it's not just the people at Q, it's all the people that are above as well, right? Because if I change the marginal price, right, that like makes the price for everyone who's buying more than that a little bit higher. So there's like all of the people who are buying a quantity that are above that level, those are like my inframarginal consumers, right? And my marginal consumers are the ones who are at this level and who would buy less if they, if the price increases, right? So yeah, so there's like two things that are relevant. One is how many people are above this level relative to how many people are at this level. And the second is how elastic are the people at this level? How many of them would switch down the number of units that they're buying, right? Okay. So we gain $1 from everyone who's buying more than that many units, right? And we lose the markup that we were earning on this unit, the difference between the marginal price and the marginal cost of that unit, of selling one more unit of quality, times the number of people who are at that level, times the fraction of those people who would switch down, right? Okay, so if we define the elasticity of demand as the how many people would switch down divided by how many people are buying, right? This is sort of like the Q in the elasticity of demand, right? And this is the Q prime, and then P prime is like the price. It's like the price for that marginal unit, right? Then the first order condition is just the Lerner condition, right? It's that my marginal price minus the marginal cost, the cost of providing that additional unit of quality divided by that, is equal to 1 over that elasticity, right? The elasticity, again, is how many people are going to switch down divided by how many people are buying above that level multiplied by the my marginal price at that point. So this is sort of like I have this whole schedule of marginal prices, and I'm doing this monopoly trade-off at every point along that schedule, right? And this sort of analysis is really nice. It's used often for doing tax policy, because you can think about also in tax policy at any level, if I increase the marginal tax rate at this point, I get an additional $1 from all the people who earn income above that. But then there's some elasticity of people who are exactly at that tax level, right? And that's sort of the trade-off that I make. And it's just that elasticity of labor supply, right? Now, the problem with this is to really exploit this formula, you need to know the elasticity at every point along that curve, right? And that's pretty difficult to do. You can't just have some average elasticity or something like that, right? So Wilson investigated data, and he found that in reality, the elasticities and so forth don't differ enough that it's really important to charge a different marginal price at every point. Instead, he found that if we just have a few part tariff, where like, you know, if you for buying between this and this range, you pay this marginal price. For between this and this range, you pay another marginal price. That almost always does a quite good job of approximating the optimal solution.